I think that you should know how to do this kind of problem already because it doesn't involve any concepts that you don't already know. But maybe you want some reassurance by seeing an answer. So I want you to try this problem. I'll explain it in a second, and then we'll look at the answer, and I'll solve it. So let's say we've got a function f of x, which is x squared minus p for some p-value that's larger than 0. We don't know what p is. But then let's say I also tell you that we know that f of 2 is 16. That's enough information to be able to figure out what p has to be. So why don't you give this a try? All right, let's take a look at the solution. So let's expand this. Let's substitute f of 2 with what you'd actually get if you expanded the f with its equation. So let's just look at the inside here. F of 2 is what we get with the f function when we plug in 2. So that should be 4 minus p, because 2 times 2 is 4. So now let's figure out what is f of 4 minus p. So f of 4 minus p means I'll plug in 4 minus p for the x value. So that gives us 4 minus p squared minus another p. And if I wanted to expand this out, that would give me 16 minus 8p minus p squared, and then this minus p is still there. Oh, sorry, not minus p squared, plus p squared. Okay, and so what we know is that that left-hand side equals 16. So here's 16. And now we have an algebraic equation that we can solve because we only have one variable, p. So let's start by subtracting 16 from both sides. I can factor a p out of all three of these terms. So that gives me, well, let's do this in more steps. So I'll reorder these. So p squared minus 9p equals 0. 0 because I subtracted the 16. And then I combined the minus 8p and the minus p to become minus 9p. If I want to, I can factor a p out. So that gives me p times p minus 9 equals 0. And so I know that two solutions for p would be p equals 0 or, excuse me, or p equals 9. However, I know it can't be p equals 0 because originally it said that p has to be larger than 0. Therefore, the answer is p must be 9. Let's do another similar one. So now that we know that p is 9, I'll write f of x as x squared minus 9. What if now I told you that f of 3k for some number k equals 72? So what's k? It's really very much the same thing. So let's evaluate first what is this inside f of 3k. So I'll plug in 3k for x, and that gives us 9k squared minus 9. And now if I evaluate f of that, that's going to give me 9k squared minus 9 squared minus another 9. And we know that that's equal to 72. So let's solve it. I'll add 9 to both sides here. So that gives me this squared is 81. I'll take the square root of both sides. So that gives me plus or minus 9 here. Let's divide through by 9. So that gives us k squared minus 1 equals plus or minus 1. And then last, let's add 1. So I've got k squared equals 1 plus or minus 1, which is the same thing as 0 or 2. So if k squared is 0 or k squared is 2, that means that k equals 0 or k equals plus or minus root 2. So there are 3 possible values for k that would all work. Sometimes it's worthwhile just to go back and double check that it actually makes sense. So let's evaluate it with 0. So f of 0 would be negative 9, and then f of negative 9 would be 9 squared minus 9, which would be 72. So that seems like it works. What about root 2? Let's write this one down. So f of 3 root 2 is going to be 9 times 2 minus 9. So that's 18 minus 9 equals 9. And then f of 9 is, again, 81 minus 9 is 72. So that works. If you think about doing the same operation with negative root 2, the negative root 2 becomes positive when it squares, so you'll end up getting the same thing in the end. Great, so that was just a quick sense check to make sure that these answers will still work. Okay, so now I'd really like to know, how did this problem solving feel to you?